In this video, we introduce the definition of exponential functions by considering various kinds of expressions involving exponents. Let's begin by reviewing the types of functions we have seen in past experience. We have a lot of experience with polynomial functions. Note that polynomial functions have a variable base with a constant positive integer exponent. A classic example is f of x equal x squared. After polynomial functions, we typically encounter rational functions. In their most basic form, rational functions have a variable base with a negative integer exponent. A typical example is f of x equal 1 over x, which is x to the negative 1 power. Radical functions are functions involving a radical or root. Recall that radicals can be described with fractional exponents. Thus, a typical radical function might look like f of x equal x to the 2/3 with a variable base and a fractional exponent. Exponential functions also have a base and an exponent. However, exponential functions have a constant base with a variable exponent. For example, f of x equals 2 to the x power. Let's consider evaluation of this function. Note that evaluation is easy for integer values of x. F of 1 equals 2 to the first power, which equals 2. F of 3 equals 2 to the third power, which is 8. F of 0 equals 2 to the 0 power, which is defined to be 1. F of negative 1 is 2 to the negative 1 power, which equals 1 over 2. F of negative 3 equals 2 to the negative 3, which is 1 over 2 cubed, or 1/8. Let's continue to evaluate f of x equal 2 to the x for rational values of x. Recall that expressions involving rational exponents can be written using radicals. So f of 1/2 is 2 to the 1/2 power, which is defined to be the square root of 2, and that's approximately 1.414213. Similarly, f of 2/3 is 2 to the 2/3 power, which equals the cube root of 2 squared. We can approximate this by 1.587401. We can continue to evaluate f of 1.7 by converting 1.7 to the fraction 17/10 and using radicals. And so on. Of course, we are using a calculator to get numerical approximations for these function values, but the important point is that we do know how such function values are defined and evaluated. The question then is how to evaluate f of x equal 2 to the x power for irrational values of the exponents. We will use rational approximations. Suppose, for example, that we want to evaluate f of the square root of 3, that is, 2 to the square root of 3. We start with a rough approximation. The square root of 3 is approximately 1.7, and use radicals as before. We can use a better approximation of the square root of 3 as 1.73, or an even better one at the square root of 3 as 1.732, and we can continue approximating the square root of 3 with more and more decimal places until we get a good enough value for f of root 3, which is 2 to the square root of 3. A calculator will evaluate f of root 3 as approximately 3.321997. In general, we use a calculator to produce approximations for exponential functions at irrational input values. Now we can give a formal definition of exponential functions. For positive a not equal to 1, the exponential function with base a is given by the function f of x equals a to the x. We might need to elaborate on the two restrictions that a is positive and not equal to 1. First, consider what might happen for negative a. Let a equal -2 and suppose x is a half. Then f of a half is -2 to the 1/2 power, which is the square root of -2, and this is not a real number. Therefore, we require that the base a be positive. Now consider what will happen if a equals 1. Then f of x equals 1 to the x equals the constant function 1, which is not an exponential function. Thus, we also require that a is not equal to 1. Now that we have a good definition for exponential functions, the next few videos will consider the properties, graphs, and applications of such functions.